Hi, my name is Ting Kah Lee, ID 1800140, and I will be presenting for challenges and recommendations.
I'm Mindy ID 1800222, and I'll be talking about the results of the experiment with discussion.
Hi, my name is Najmi bin Zakaria, ID 170102119, and I will present the introduction and conclusion.
My name is Syaidatul Arfah Binti Shamsuddin, ID 180022225, will be presenting problem statements and also objectives.
The increases of the waste disposal from chemical process industry due to the massive growth in population and the industrial activity has urged the world to implement the zero waste management approach to slow down the climate change effect and protect the ecosystem. The wastewater treatment plays a crucial role in the continuous supply and production of the clean and good water quality. The quality of water is measured by its various physical and chemical properties such as temperature, dissolved solid content, acidity, dissolved oxygen, hardness, and many more. Industrial sectors such as textile and palm oil industry utilize large amount of water and produces even larger volume of wastewater from different stages of its production plant. The imbalance of the pH value of a discharged wastewater from a poor efficient chemical operation and spillage can cause serious pollution hazard and endanger the ecosystem. According to research, the universal standard pH value of the wastewater discharge must within the range 6 to 9, depending on the type of industry and the tolerance.
We have come to the problem statement part. Malaysia is one of the developed countries that produce massive amount of waste. However, the standard management of waste in this nation are still at its minimum level. The main source of wastewater production is the public sewage treatment plant that not only contain industrial debris but also harmful microorganisms, for instance viruses and also bacteria. Moving on, the water quality and also the pH value are correlated with each other, as the instability of the pH value could lead to detrimental of the water usage and also reducing the effectiveness of the wastewater treatment itself. Therefore, an advanced control is often utilized in a plant to ensure its profitability while maintaining a safe and of course effective operation towards the treatment by understanding control loop system. Here are the objectives of this study, which firstly to achieve the industrial goal of zero waste in the wastewater treatment, to study the implementation of control system in the pH neutralization application, then to investigate the challenging concerns of the chosen control system, and last but not least to provide recommendation as for improvement towards the overall project.
In this lab experiment, pH neutralization pilot plant is used to demonstrate the neutralization process in industry. Based on this pilot plant diagram, where the experiment is conducted, the pH neutralization system consists of two liquid streams, one feeding the influent stream consisting of hydrochloric acid, while the other one feeding the reagent stream, sodium hydroxide. To regulate the pH of the effluent stream, the acid flow rate is kept constant, while the sodium hydroxide flow rate is continuously varied in steps using control valve. The whole neutralization process is regulated by a controller. Proportional plus integral mode is the most commonly used control pattern for pH neutralization process in wastewater treatment plants. The addition of integral mode to this proportional band helps to eliminate the offset and therefore advance the controller output and the final control element position. In this experiment, we aim to determine the tuning parameter of the PI controller. After a few trials and errors, it's suggested that 18 is the optimal value for the ultimate proportional gain GU, as the pH value response in the graph appeared to show a constant amplitude of oscillation repeatedly at this value. After getting the ultimate proportional gain value and the period of oscillation, we can calculate the proportional gain and the integral gain of the PI controller using the Ziegler-Nicholas method. From calculation, Kp value is 18 and Ki is 0.29. The second experiment is conducted to check the performance of the PI controller with respect to setpoint changes. From the simulation graph, the pH value response displayed overshoot subjected to sudden setpoint change and offset is present at steady state. This indicates that the integration can be further increased, whereas from the graph below, the alkali flow rate fluctuates. In short, the overall performance of the PI controller is less encouraging. In experiment 3, a comparison between calculated and implemented integral gain value is conducted. This simulation graph shows that when the integral gain value is 0.29, the pH responses demonstrated a slightly higher overshoot and longer settling time. However, the offset is relatively smaller as well. This experiment proves that the larger the Ki value, the pH responses become more aggressive, display larger overshoot, increased settling time, and better at eliminating offset.
Based on our research, we found out that there are a few challenging concerns for process control for pH neutralization of textile wastewater. These challenges need to be identified and minimized to improve the control system. The first challenge is the non-linearity of pH neutralization. Nonlinearity is deemed as the most crucial problem faced in the neutralization process. Some of the causes are the changes in feed condition, neutralization process time delay, fluid density of acid and alkali, fluctuation in flow rate, the time-varying characteristics of pH process, and etc. In addition, neutralization process will often be subjected to immeasurable and unpredictable disturbances. The second challenge is the presence of different heavy metals in textile wastewater. Precipitation is important to allow these heavy metals to be separated from the water. However, different ions precipitate at different pH, which means that automatic control system is needed for each stage to neutralize heavy metals present. This is a very tedious process. The third challenge is the operational problem of pH sensor. Some of the problems that they may encounter during operation are contamination, breakage, failure, fouling, plugging, and poisoning. The fourth challenge is the different pH values of wastewater streams. It is very complicated to develop mathematical model for pH process control, as the process dynamics can change significantly just because of small change in quantity of polluting elements. To overcome these challenges, few recommendations have been explored to improve the problem stated. The first recommendation is to apply the fuzzy logic control system. Fuzzy control works for pH process because first, it does not require us to formulate any transfer function or complex mathematical analysis. Second is that the pH range can be easily divided to be tuned separately, providing easy control. Fuzzy logic control is becoming a heavily used technology due to its user-friendliness, simplicity, effectiveness, and efficiency. In the fuzzy logic control system, there are four main elements, which are the rule base, the inference mechanism, the fuzzification interface, and the defuzzification interface. The application of fuzzy control solves all the non-linearity issue by overcoming limitations of PID controllers. The second recommendation is by maintenance of pH sensor. Frequent cleaning and calibration using non-porous reference junction electrodes could eliminate most of the pH sensor problems. The third recommendation is adaptive control. Adaptive controls can be used to solve problems other than non-linearity. Examples include the multimodal adaptive control, the quantitative feedback theory QFT, and the robust loop shaping approach. All the controls mentioned seem to be effective at resolving the disturbance control issue.
In the conclusion, the wastewater treatment issue are the problem that need to be addressed significantly, and it has direct impact to the ecosystem. The application of the controllers such as PI controller in the pH neutralization process could help increase the quality of the discharged wastewater. Among the recommendations that could be applied to improve the control system are the utilization of the fuzzy logic control system, maintenance of the pH sensor, and using the adaptive control method. The improvement of the pH neutralization of the wastewater treatment could contribute to the zero waste management approach, as it minimizes the threat towards the environment, including the aquatic and human life.